All right, guys. So we're going to go ahead and get into these notes. This is going to be 2.3 solved by elimination. Day today is the 13th. An objective for today is we're going to be talking about the third and final method that we're going to use when we are solving systems of equations. So we've talked about graphing so far. We've talked about substitution. Now we have one more way to do this algebraically where we can solve these systems. And as a reminder, we're always solving for x and we're solving for y on these problems. Okay, on this video, make sure you're either watching with headphones in or watching with captions on just so you can see the explanations. And then also make sure if you ever need to, slow down or anything like that to write some of these notes down, feel free to pause and then continue the video when you're ready. Okay, so just like we talked about yesterday, we're going to have some steps that we're going to use for this method here. So with elimination, we have 4 different steps that we really kind of want to pay attention to. So first thing I want to do, the first step is I want to basically create opposite values in both equations. Or let's say, I'll say create opposite values between the 2 equations. That'll be a better way to put it. I want to create opposite values between the 2 equations. So for example, when we talk about opposite values in mathematics, what we're referring to is, for instance, values such as, get this pulled back up on the screen here. Values such as positive 10 and negative 10, or positive 4 and negative 4, things like that, opposite of each other. Okay, so we want to look to create those opposite values between the 2 equations, and then that's going to lead us to our next step, which once we have those, we're always going to add the 2 equations together. Okay, we're going to add the 2 equations together. And the reason this is important is because if we have opposite values and we add them together, then what's going to happen is it's going to be canceling out one variable. So if we've created opposite values, or if we've just been given opposite values from the very beginning, and then we do this correctly and add the 2 equations together, one of those variables is going to get canceled out or eliminated, which is why we call it this. Okay. Next thing here, once we have one of those variables canceled out, it's kind of similar to what we did with substitution. We're going to solve for the remaining variable. Okay, try to fix that here. Solve for the remaining variable, whatever's sitting left over. And then lastly, we didn't really add this to the notes on substitution, but it's the same kind of last step with these kinds of problems as well. Is once you've solved for one variable, last thing you want to do is you always want to plug in what we find to solve for the last variable. Could be a way that we say that here. Okay, so again, kind of like we saw yesterday, we would solve for x, for instance, and then we'd plug that back in to find out what y is. Same thing here. Once we solve for one of them, we plug it back in, solve for the other. Okay, so I know this is a lot of steps and a lot of technical words, so let's try to see it in an example here and see what I'm referring to. So example 1 here, I want you to take a second, pause the video, and I want you to write this system down for me. 2x plus 5y equals 24, and 6x minus 5y equals negative 8. Okay? So if we're looking at our first step, the first step we said is we're going to create, or hopefully sometimes we're given, opposite values between the 2 equations. And so if I look at these 2 equations here, I see that I have positive 2x and positive 6x. We know those aren't opposite of each other. But then when I look at the y values, I'm actually given 2 opposite values here, positive 5y and negative 5y. And these are the opposite values that I'm looking for here. So that is step 1, is trying to create those. In this case, like I said, we're just given them. Okay, so then we move on to step 2 here, which is once we have those opposite values, we're going to add the 2 equations together. And so if I look here, I'm going to draw a line underneath both equations, and I'm going to turn this into a big addition problem. So just like you learned addition when you were first starting out, you would put two values over each other and just add them together. Same idea here. So I'm just going to add down these columns with my like terms here. So I'm going to add the x's together, I'm going to add the y's together, and then I'm going to add the numbers together. So when I add the x's, I have 2x plus 6x. That's going to give me 8x. When I add the y values, I have a positive 5y and a negative 5y. And since those are opposite of each other, they will cancel each other out or eliminate. And that's where elimination comes from. All right, and then on the last side here, we have the numbers. So we have equals, and then we have 24 plus negative 8. Or in other words, 24 minus 8, which would be 16. All right, and then this is very nice. Last step, all I need to do is divide by 8 to solve for the remaining variable here. And I get x equals 16 divided by 8, which is 2. So this is our goal, is to eliminate one of the variables, so then we only have one left to figure out, and then we just use our algebra skills to solve for it. And as we've discussed, once we get done and find one variable, step 4, we need to plug that back in to solve for the last variable that we have. And so I'm looking at these two equations here. And the good news is, like we talked about, I can plug it in either to the first or second equation. It doesn't matter. I'm going to go ahead and plug it back into the first one because it looks like the multiplication is going to be a little bit simpler and I only have positive numbers there. So if I rewrite this, knowing that x equals 2, I would say this is the same as 2, and then instead of x, I'll plug in 2, and then plus 5y equals 24. And now we just need to solve for y. So make sure you do your order of operations. I have 2 times 2 there, which is 4, plus 5y equals 24. Next step, this is a positive 4, so I'm going to subtract it. Subtract it to get 5y equals 24 minus 4, which is 20. And then last step here, divide by 5, and I get y equals 20 divided by 5, which is 4. Okay? So that is the idea, is we're eliminating one of the variables so that we can solve for one of them. And then as always, plug it back in, same thing that we kind of saw with substitution here. Okay, these problems do take a little bit of time, but the hope is that we can solve these and make sure we're getting the right answers. Okay, so let's look at a few more examples of this, because there's other situations that you'll kind of run into here. So example 2, I want you to take a second, I want you to write down this system of equations for me. Let's say we have 3x minus 14y equals 10, and then negative 7x plus 7y equals 28. Okay? So if I'm looking at these two equations here, notice our first step is still the same. I want to look for, or I want to create opposite values. So between positive 3x and negative 7x, those aren't opposite of each other. Okay, one's positive, one's negative, but they're not opposite. Okay, and then same thing with negative 14y and positive 7y. Okay, notice these two numbers are opposite of each other, but they're in the same equation. I want the opposite values in the separate equations, and I want them to have the same variable. Okay, so what we're going to do here, if this is why I kind of wrote this on the first step, if we don't have opposite values, then I'm going to create opposite values. And so what I can do here is I see this is a negative 14y, and I notice this is a positive 7. If I multiply this by 2, then that's going to equal positive 14y, and now I would have opposite values, negative 14y and positive 14y. And so I can do that. I can multiply this by 2, but if I multiply this by 2, I have to multiply everything in that equation by 2. Okay, this trick works as long as you multiply everything. And so I'm just going to write this new equation over here when I multiply everything by 2. So negative 7x times 2 would now be negative 14x. 7y would now become 14y like we talked about. And then 28 times 2 would give me 56. Okay, notice the other equation, I don't have to change at all because it already has the opposite value that I was looking for. So I can just rewrite that 3x minus 14y equals 10. And now when I look at these two equations, now I have opposite values between the y values here. And notice, and we'll talk about this later on, it doesn't always have to be the y values that are canceling out. It can also be the x values. It doesn't matter as long as you're canceling out one of the variables. Okay, but now we have those opposite values, so we'll go on to step 2. Okay, if it helps to draw these columns, feel free to do that. But I'm looking at these here. I'm going to add this, so I'm just going to treat this like a big addition problem. So I have 3x plus negative 14x. That's going to give me negative 11x. Negative 14y and positive 14y added together. Those are the opposite values, so those will cancel. And then lastly here, I have positive 10 and positive 56, and that'll give me positive 66. And now, like I said, we have a very nice and easy equation to solve for here. So we're going to divide by negative 11. Oops. divided by negative 11 on both sides, and we get x equals 66 divided by negative 11, which is negative 6. Okay, so make sure you're keeping track. That is a negative 6, because that is going to be important, because now we need to plug it back in to one of our equations. And like I've discussed, or like I've said, it doesn't really matter which equation you plug it back into. You can plug it back into the first one, you can plug it back into the second one, and in fact, you could even plug it back into this third one that we actually created. Any of those would all give you the same answer. I'm going to choose this one right here because it looks like the number next to x is the smallest, and so the multiplication is going to be easier than anything else, okay? But again, it doesn't really matter which one. So I'll plug this back in here. So I have 3x minus 14y, so 3 times negative 6 minus 14y equals 10. And just like before, let's solve for x here. So 3 times negative 6 would be negative 18. And then minus 14y equals 10. Next step, add 18 to both sides. I'm getting numbers on one side, so I have negative 14y. Don't forget this negative here. A lot of you guys like to not bring that down. So negative 14y equals 10 plus 18, which is 28. And then last step here, divide by negative 14. Oops, negative 14 here, which means our answer is going to give me negative 2. So as we kind of saw on our last test, make sure you're paying attention to when answers should be positive or negative. My final answers are going to be negative 6 and negative 2. All right, a few more examples here, and then I'll let you guys get to it for the homework for today. Next one here, same concept. I have two equations, so you can take a second, pause your video, and write these down. 5x plus 6y equals 11, and negative 10x minus 12y equals 22. So same thing I see before. I'm checking for opposite values. I don't see these here. And so now let's focus on trying to figure out how we can multiply maybe one of the values by something in order to have opposite values. Well, I notice this is a positive 5x and this is a negative 10x. If I multiply this by 2, then I would have positive 10x. And so I can do that, but remember the trick is if I'm going to multiply one thing by 2, I need to multiply everything in that equation by 2. And so I go here, I go to multiply everything. So 5x times 2 is 10x. 6y times 2 is 12y, and 11 times 2 is 22. And then this other equation, like I said, I don't have to change it at all, so I can just move it over. Negative 10x minus 12y equals negative 22. Okay, and so now we're going to do our same trick here. I have opposite values. I'm going to turn this into a big addition problem. And I can set up those columns if I need to. So positive 10x and negative 10x added together are actually going to cancel out, as we were trying to do. When I look at positive 12y and negative 12y, those also cancel out as well. And so this is a rare situation where everything on the left side of the equation has canceled out, but I do need something over here. And so since everything's canceled out, I'll just put 0. Okay, and then on the other side here, we have 22 plus negative 22. And actually that same kind of thing ends up happening. They basically cancel out, or in other words, positive 22 plus negative 22 is also 0 as well. So I get down to the end of my problem, and we talked about this before. If I get to the end of a problem and I see that all my variables have canceled and I just see a statement with numbers, it's either no solution or infinite solution. And in this case, since this is a true statement, since 0 does equal 0, that is infinite solutions. Okay, so just notice you will run into those kinds of situations here. All right, and then one last one that I want to talk about, example 4 here. I want you to take a sec, pause your video, and I want you to write this system down for me here. Let's say we have 3x minus 5y equals 7, and 2x minus 7y equals 23. So I'm looking at this system, and stay with me guys, it's our last one here. I notice that I want opposite values, and I actually am not really close in any case of getting opposite values here. I see a positive 3 and a positive 2, and I see a negative 5 and a negative 7. And so none of those are close. If I multiply one of the equations by something, I still can't get opposite values. And so this is one of those rare cases where you're actually going to have to multiply both of the equations by something. And so you can choose whether you are going to try to cancel out the x terms or the y terms, but you need to try to multiply each of them by something so that I do have opposite values as we've been discussing. So for instance, I'm just going to focus on the x's here. I see 3x and 2x. I notice that I can multiply both of them by something to get them to be 6x, because 2 and 3 both go into 6. So if I multiply this whole top equation by 2, then that will create 6x. But I just need to make sure to multiply everything. So 3x times 2 is 6x. Negative 5y times 2 is negative 10y. And then 7 times 2 is 14. Okay, and then as for the second equation, I want to make this 6x as well. So I'm going to multiply it by 3. But remember, we didn't say we want the same values. We want opposite values. So I don't want this to be positive 6x. I want it to be negative 6x. And so how I'm going to change that is I'm actually going to multiply the bottom equation by negative 3. So negative 3 times 2x is negative 6x. And now I have opposite values between these two, which is what I want. And then we continue here. Negative 7y times negative 3 is positive 21y. And then last one here, positive 23 times negative 3 is negative 69. Okay? So we have this here. We have our opposite values. Sometimes you're going to have to multiply both equations, and then we'll just add these together like normal. So I'll add these here. Turn this into a big addition problem. We have positive 6x and negative 6x. Those cancel. I have negative 10y and positive 21y. When I add those together, that would give me 11y. And then when I have positive 14 plus negative 69, I'll get negative 55. Okay, and I'll just roll through this last part quickly because I know you guys know how to do the rest from here. Divide by 11, and you get y equals negative 5. And then we plug back in. Doesn't matter which one we plug it back into. I'm just going to choose the first equation. So I'll bring this over here. 3x minus 5 times negative 5 equals 7. Multiply those negative 5, so I get 3x plus 25 equals 7. Subtract 25 from both sides. 3x equals negative 18. And then divide by 3, and I get x equals negative 6. Okay, sorry if I went through that last part kind of quickly, but like I said, I hope you know how to do that, and if you didn't write it, that's okay, as long as you understand the steps, okay? So that is elimination. We'll practice that more when I get back, but in general, I want you to try to do some of these problems from the homework today that I've posted, and I want to make sure that you can use this method a little bit and you had these notes, okay? So if you guys have any questions, feel free to let me know when I get back, but otherwise, the rest of the time today, you are working on the 2.3 homework post on Google Classroom. All right. If you have any questions, feel free to let me know.